Right. In this series of video lectures, we basically want to study and construct a manifold structure on homogeneous spaces. And the setup is as follows. So we have G, a Lie group, and H, a closed subgroup. And then the set we want to be looking at is this coset set. So those are all the cosets where the G is varying through the group G. And the idea is, or our goal is to basically build a manifold structure on this quotient space. And well, how do we do this? Plan of the construction. Well, as far as we know, for now, this G mod H is just a set. So maybe it's a good idea, first of all, to put a topology on G mod H. So this will be the quotient topology, and establish some of its properties. So this will be the lemma for 2.4. That's where we need a little bit of topological group theory to do this. Then, as a preparation, so for preparation, basically for the chart construction, we need some auxiliary results, because it turns out that, at least in this case, when we have a Lie group, we can exploit the Lie group exponential to get something which is amenable to charts on the or at least amenable to this quotienting process, which will then give us a chart on the coset space. However, this will be a somewhat technical argument. This will be recorded in lemma 425, which we will see later. And then finally, we construct with our auxiliary results an atlas of this coset space G mod H, and prove some elementary properties for this. So what do I mean by these elementary properties? Well, for starters, we get a group action on the coset space, well, which is just, we're taking an element, we're taking a coset for this element. So let's call this G tilde times H. We're sending it to the coset, which is the product of those two things. Okay, so this is a canonical action. Let's call it maybe sigma. And what we want to see is that this is a Lie group action. And actually, this is from a perspective why this coset space is a homogeneous space. We can use the natural action of the Lie group to transport things from the neighborhood of one point in the coset space to any other. And so it's easy to see that this action is transitive. This is a transitive group action. And this also explains our interest in these homogeneous spaces, because they are an easy example of, well, hopefully after we're done with the proof, manifolds on which Lie groups act in an hopefully easy to understand way. At least there's just one orbit. That's basically what transitivity means. So we can reach every point from every other point by means of the group action. And we will use this to study some examples.